Speaker is Nate Aune. He's going to introduce us to the ever-changing world of Python as a service providers, and let's give him a welcome, a warm welcome.
Thanks, Carlos. So how's everybody doing? Hanging in there first day? All right. So I gave a similar talk last November I'm from Boston, and gave a talk on Django deployment. And I went into a lot of detail about sort of how you deploy your Django apps. And this is a Python crowd. I'm still going to be talking about Django, but hopefully it'll be applicable to those of you who are using something else like Flask or Pyramid. And I also want to talk today more about the why. Like, why would I even want to use a PaaS? I've been using, a VPS or Amazon, and it's working for me. So why would I consider using a PaaS provider? So that's what I'm going to be talking about today. And I have the old version of my talk up on my blog, which has much more details about how to actually start using the PaaS providers. So a little bit about myself. I started Jazzcarta, a web consulting firm, back in 2004. And in 2006, I got my first taste of cloud platforms. That was when Amazon first came out, and we jumped right on the bandwagon, and we were deploying our own website to Amazon. This is back before they had EBS. So we were doing like, S3 backups every 15 minutes, real living on the bleeding edge. And then a couple of years later, I started experimenting with Google App Engine. We did a consulting project on Google App Engine. That was when I got my first taste of, this one-click deploy experience. Like, I didn't have to touch a server. I was able to just deploy my Python application up to Google App Engine, and voila, it's running. And that was like a revelation for me. But back then, you still couldn't really deploy native Django applications. So in 2010, I started Django Zoom. And at the time, there was nothing equivalent to HEROKU for Django developers. So I thought to myself, hey, I'll build my own PaaS. How hard can it be, right? As it turns out, it was really challenging. And we got some traction, but last year we decided to shut it down. There's simply too much competition from really big players. And for us, from a business perspective, that meant a race to the bottom. So I started a new company called AppSembler, which is a marketplace of open source web applications that you can deploy with one click. If anyone here is interested in hearing more about that, if that's interesting to you, I'd love to talk with you more. So what we're doing with AppSembler is we're leveraging PaaS, and essentially we SaaSify web applications. So you have an open source web app that you want to turn into a SaaS product. You can connect with your GitHub account, you can push it up onto AppSembler, and within a few minutes you can be selling your app as a SaaS product. So as part of this new business, I've been looking at all the different PaaS providers and really digging in deep and trying to figure out what the pros are, what the cons are, and I hope today to share some of that experience with you. So a little bit about what we're going to be covering. First of all, why should I care, right? Like, why would I use a PaaS versus just use what's working for me right now? And then we'll talk about what is a PaaS and what are the advantages. And there's a lot of them out there right now. If you walk around in the exhibits hall, you've probably seen, there's half a dozen different companies that are providing platform as a service. And then why might you not want to use a PaaS? It's not for everybody. Okay, so a quick poll of the room. How many people here are using something like shared hosting, like WebFaction? Raise your hand. Okay. How many people are running your own servers, co-locating? Okay. What about using an IaaS provider like Amazon or Rackspace? Okay, so most of you here. And how many of you are already using a platform as a service provider? Okay, great. Who still hasn't deployed their first app? Anybody? Okay. All right, so I want to tell a brief story. This is Dave, who I met in San Francisco. And as you know, everyone and their dog has a startup in San Francisco. So Dave is the CTO of a startup called Crowsource. And this is the world's leading marketplace for crow-based labor. So they train and hire thousands of crows to complete microtasks for you at very competitive costs. So Dave has a number of challenges as the CTO of this rapidly growing startup. He's just been tasked with deploying the first beta version of CrowSource. And where's he going to deploy it? Amazon, of course, right? That's where everyone deploys it. So what is he going to have to do? He's going to have to decide, what size Amazon EC2 instance to get. How much memory, how much disk. He's got to SSH into that machine, configure all the dependencies, make sure he's got Apache and MySQL and everything installed. He's going to have to, do a lot of manual stuff, and he feels dirty, going and SSHing, but he's under time pressure. So this probably is going to take him a couple days just to get this machine configured properly. And then he's been a technical guy long enough to know if you don't have backups, you're screwed. So he spends another day setting up cron jobs, making sure his data is getting backed up to S3. So that's probably going to take him another day or so just to test the backup restore. And then gotta look out for the bad guys, right? He's got to have SSL set up for his logins. So he's got to install SSL certificate. That's going to probably take another day to make sure that's all set up with Apache and putting everything where it needs to go. So that that's another day. And it's really starting to take off. CrowSource just got mentioned in TechCrunch. And so he's got to resize his server, right? He's got a small. He started on a small because it's cheap, but now he's got to upgrade that to a large. And he's got to get Celery and RabbitMQ installed for processing all his background tasks. Memcache, he's got to get that installed. So it's going to take him, a few more days to get all that stuff set up. And then he has that oh shit moment. Have you all had that oh shit moment? Who's managed servers before, right? You probably had this oh shit moment where you're like, oh crap. So he accidentally pushed a change to the server that wasn't fully tested, brings down the whole site, right? His CEO is not happy with him right now because he's just borked the site and they're getting tons of traffic. So he spends the next 2 days recovering from this mistake. Luckily, he had backups, so it wasn't as bad as it could have been. But he goes to his CEO and he says, managing these servers is not a good use of my time. I'm the CTO after all. We have to hire a DevOps guy. So he finds a DevOps guy for $80,000 a year salary. And what does he do on the first day of his job? He's training the new guy. So he spent another day showing the new guy how this kind of ad hoc hodgepodge system is set up. So, question you might be asking is, he just spent 8 days dealing with issues. He's got relief on the way, but it's coming at a huge cost. So what if he didn't have to deal with servers, nor spend $80,000 on a DevOps guy? So is this the moment where I try to convince you that using a PaaS is faster, cheaper, easier? First, I will define what a PaaS is. So platform as a service enables developers to create innovative applications without operational overhead around configuration, deployment, and management. So what does this mean? You've probably all heard of SaaS. Infrastructure as a service is another acronym that we use when we're talking about cloud hosting providers like AWS or Rackspace. And PaaS sits somewhere in the middle. It provides what we call the platform. So what do we mean by that? Well, if the infrastructure service is things like the network, the storage, the servers, the virtualization, the PaaS provides the operating system, the runtime, the middleware, all this other stuff that you would otherwise have to configure yourself on the server. So there was a survey last year, and the most highly rated benefit of PaaS was the operational improvement, followed by development and cost reduction. And in that same survey, 2 out of 3 respondents use or plan to use PaaS within the next year. And Lucas from AppFog, one of the other PaaS providers, argues that over the next few years, over the last few years, the cost of hosting apps has exponentially decreased, while the productivity has exponentially increased. And we're seeing that trend today. So why does it keep getting cheaper while developer productivity keeps going up? Well, with PaaS, you have a lot of apps co-located on a server. And the benefits is that this drastically reduces the amount of resources that you have to use. And it also gives you the flexibility so you can add or remove capacity depending on your load. And all this is secured using something like SE/Linux or LXC. So the bottom line is that you can let the PaaS providers do all the boring stuff, things like the patches and the updates and migrating the applications and backups and snapshots, configuring everything, the web servers, the load balancers, databases. These guys have ops teams that are working 24/7, which allows you, as the developer, to spend more time solving problems that are unique to your business and not the standard things that everybody has to do. Okay, so now that's a bunch of fancy graphs, and I know what you're thinking. I want to see this in action. So as the title of this talk would suggest, I'm going to show you how to deploy an app in 5 minutes. And if you have your laptops open and you want to follow along, I've created a GitHub repo called the PaaS Bake-Off. And I've taken a Django app and set up branches for all these 5, 6 PaaS providers. So you can do diffs between the branches and see how they compare to each other. Okay, so here we go. There's a timer in the upper right-hand corner, so you can follow along. So we're going to create a new branch. Going to call it MES-PyCon. And we're going to use Heroku to create a new application. And once we've done that, we're going to go in and create a requirements file that says what our dependencies for this application are. So we just need Django, Mezzanine, our Postgres database, and this little helper application called the DJ database URL. Next, we're going to create what's called a proc file. And this is what Heroku uses to know what process to run when our application starts up. And this is something special we need to do with Heroku to serve our static assets. This is not generally recommended in a production environment, but I only had 5 minutes. So I'm showing you the quick and dirty way of doing it. Next, we are going to replace the databases section with the database that Heroku provides for us. And this is exposed, again, through these environment variables. And now we're going to actually tell Heroku, go out and create a Postgres database for me. So that's one command. It goes provisions the Postgres database. And then Heroku uses Git to do the actual deploy. So we need to push our changes to our Git repo. And the last thing we do is run git push Heroku. And normally you'd say Heroku master, but because I'm working on another branch, I have to say my branch : master. And let her rip. Okay, we're at 1 minute and 43 seconds. So this is going to be the longest part of the deploy, is actually waiting for Heroku to run this. So what Heroku is doing now is it's going out and it's looking at my requirements file. It's installing all my dependencies, including Django, including Postgres. You see the clock is going very fast. I'm saving us some time here. When it's done with that, notice it also collected our static files for us. So it detected it's a Django app and it automatically ran the collect static command. Now I'm going to run the syncdb to set up all my database tables. And we've got 15 seconds left. Okay, install some sample content. Let's go over to the browser and in 5 minutes, we now have our Django app deployed. Okay, so that took 5 minutes. It's probably not the app that you would actually want to use in production. There's a lot of other things that I didn't show, such as deploying my static assets to S3. I probably want to use gUnicorn instead of using run server. There's a few other steps that I could do to sort of production-proof my application. So I want to go back to Dave and talk about the frustration Dave's having, right? He spent 8 days setting up all this stuff. What if Dave were to do those same things, but instead of setting up the EC2 server that he needs to self-configure, he instead uses a PaaS? So instead of logging into the machine and running apt-get and installing all his packages, he could do something like this. This is from a .cloud YAML file. He could just define his system packages in this file, and when he does the push, it will automatically install those packages for him. Similarly, setting up those backups on Heroku, he can just say, Heroku PG backups capture, one command, and all of his data is backed up. Similarly, the restore is another one command. That takes another 5 minutes to get that set up. The SSL certificate, another 3 commands, and he's got that SSL certificate installed on his machine, another 5 minutes. That TechCrunch article comes out. He needs more server capacity. He can just run the scale command and add more workers to his instance. Similarly, there's caching services that are available through Heroku, and many of these other PaaS providers have similar services like this. Another 5 minutes to set up caching. And if we put these side by side, we're looking at, with an infrastructure as a service, spending days, babysitting the server and getting it all configured. And with PaaS, it just took me a few minutes. Under a half hour, I can have a fully production-ready environment set up. So, what kind of PaaS should you use? There's 3 different kinds. There's the hosted PaaS. There's what I call a DIY, which is not actually building your own PaaS like what I did, but it's using an existing PaaS but running it on your own server. And then there's a hybrid, which is sort of public with the option to go private, or private, or vice versa, private to go to public. So who are the players? There's 2 open source options, Cloud Foundry and OpenShift. And Cloud Foundry gave birth to AppFog and Staccato, which are 2 kind of variants of Cloud Foundry. Then we have some hosted offerings like Heroku and .cloud. And then App Engine and Elastic Beanstalk are from Amazon. And lastly, but not least, Microsoft. You can actually deploy Python applications to Azure now. So today, when I originally gave this talk, I only spoke about 4 providers. And just in the last week, I added 2 more, App Engine and Elastic Beanstalk. So I might run out of time. But as I said before, I'll post my slides online if you guys want to check these out later. OK, so we just saw deploying Heroku. So I'm going to talk about that one first. This was a moderately complex Django app, right? It wasn't a hello world. It had a lot of dependencies. Heroku is nice because it actually does a lot of things for me, right? You can look at that either way. Either I want it to do all these things for me, or I'd rather be more explicit about that. They were one of the first PaaS providers out there. They were Rails only. They have a really nice add-ons catalog. If you go to addons.heroku.com, you can plug in just about any kind of external module that you want. Is anyone from Heroku here, by the way? Hey there. OK, so they have this very nice minimalist control panel when you log in. Shows you all your apps. You click on an app, and you see a dashboard where you can look at the activity. You can see the add-ons. Here I've added Postgres as one of my databases. You can add collaborators that can also push to your app. And I should mention, all these providers have a free tier. So you'll see $0 is my monthly cost for running this application. All these providers want to make it really easy for you to get started with like a hobby app or something you're just playing around with. And then as soon as you want to actually put it into production and run it on a real database with a custom domain, then that's usually when the fees start kicking in and you have to hand over your credit card. So this is the anatomy of a Django app on Heroku. There's surprisingly very few files that you have to create. As you saw in the screencast, we had to go into the settings file and make a few changes to the database settings. If you're not using S3 to serve up your static assets, you have to make that change in the urls.py. Then there's the proc file, and then there's the requirements file where we had to add the dependencies. I found out after I wrote this talk that there's something called Django-Skell, which it's a repo up on GitHub that kind of bootstraps everything for you to get your app up and running very quickly on Heroku using all the best practices like compressing your assets and stuff. So that's definitely something to check out. There's also the Heroku Hackers Guide by Randall Degace. It's a fantastic ebook for only $10. So if you decide you want to use Heroku, I recommend that. Next we have .cloud. We have some people from .cloud here, Ken Cochran, and any other people from .cloud. So this was the first company to bet on polyglot. And by polyglot, what I mean is every single language under the sun they support. And I remember when they first came out, I was like, these guys are crazy. They're trying to do everything. As it turns out, they betted right, because now all the other providers are moving more towards polyglot, because they recognize that in a lot of modern organizations, you're not just going to have one language, one framework that you're using. You might have a heterogeneous environment where you're using Python, you're using Ruby for something, you're using Node.js for some other things. .cloud is very flexible. I found them to be the most Python-centric. They all use Python. I think their platform is largely built on Python. This is what it looks like when you log in. You can see your apps that you've deployed. When you click on an app, you can see what databases, what services are connected to it. You can look at your log files, you can look at your traffic, you can see some metrics, you can add custom domains. So you can do all this through the dashboard. There's a lot more is exposed through the command line tool, of course. And the anatomy of a .cloud app, a few more files to create. You can look at this as a plus or a minus. The minus is you have to create more files. The plus is that you can be a bit more explicit about how you want your database to be created. So whereas Heroku just automatically creates your database for you, and you don't really have an opportunity to say, well, I don't want it created that way. With .cloud, you can actually create a createdb.py file and be very explicit about how your database gets created. Similarly, you can create an nginx.conf file and set up any rewrite rules or anything that you want, similar to what you could do with a virtual machine, right? A VPS. And I really like having that control of being able to go in and set up my own rules in the nginx.conf file. Okay, I'm going to move along. Then we have Staccato by ActiveState. Anyone here from ActiveState? I know Diane is formerly ActiveState. Anyone? Okay. They were the first ones to do Python 3. I think now .cloud also does Python 3. One thing unique about Staccato is that they don't have a commercially hosted offering. It's designed to be downloaded and installed, either run on your laptop, what they call a microcloud, or up on Amazon or within your own infrastructure. So the idea is you can sort of have the same environment that your developers are deploying to is what they're deploying to production. So you can be on the airplane and testing your deployments, and you have no internet connection, and you're running the same commands from your laptop to do a deploy as you would be to deploying to your live production environment. So that's a pretty cool feature. This is what it looks like. Now I'm logged in as an administrator, so I can see like my cluster, all my machines. I can configure, I want MongoDB and I want Postgres, and this is as an administrator now, so I'm defining what services are available for everyone that's using my locally installed PaaS. So this is what the anatomy of a Django app looks like on Staccato. You have your settings.py that you've customized. You have what's called a staccato.yaml file, which is where you define all of your dependencies, your environment variables, all kinds of other configuration things can be snapshotted in that YAML file. Okay, I'm sorry I'm kind of flying through these, but I want to make sure that I have plenty of time for questions. OpenShift, we have someone from OpenShift here, Diane. OpenShift is made by Red Hat. They are in the exhibits hall if you want to go talk to them. OpenShift is unique because, like Cloud Foundry, it's open source, which means you can download OpenShift, run it on your own laptop. You can hack on the code and basically run your own open source PaaS if you're crazy enough to do that. It also has an auto scaling feature, which is pretty nice. So you can just tell OpenShift, I want to fire up additional workers as the load on my application increases. And they also have some integration with Jenkins, so you can tell OpenShift to run your tests up on Jenkins before you deploy your app, make sure everything is working properly. This is what it looks like when you log in. You have a dashboard where you can see your databases you've connected, and they also use Git for deployment. And OpenShift uses a .OpenShift directory, and in there you have a directory called action hooks. And your action hooks are like your deploy, your post-deploy. This is where you would put like your syncdb command, your migrate command for a Django application. OpenShift also provides a data directory, which is persisted across deploys. So that's where you can store like uploaded videos, uploaded images, that sort of thing. And then, unlike pretty much all the other providers, use a requirements.txt file to define your dependencies. With OpenShift, you have to either or you get to, depending on how you look at it, create a setup.py file. And in there, you define all the dependencies for your Python application. Okay, so I have 15 minutes left. Okay. All right, I got 2 more providers, and then I'll try to wrap it up. So Elastic Beanstalk, this is by Amazon, and they leverage EC2 and S3. They also have an auto-scaling feature, so they can fire up additional EC2 instances as your app reaches like 80%. You can say fire up more machines. This is what it looks like. You get nice pretty graphs monitoring your application. I was literally working with the guys over at the booth like an hour before this talk trying to get it working. This is the only one that I haven't successfully deployed. All the other providers I've been able to get up and running. I think they're pretty new on the scene as far as like doing Django and Python. Things are, they're still kind of working out the details. But similar to OpenShift, they have a .elastic beanstalk directory where you put all your config variables. And in the settings.py, you would put all your Amazon RDS environment variables to connect to your RDS database. Okay, last but not least, we have Google App Engine. So this used to be very sort of vendor lock-in, like you had to use the Google Big Table, and you had to basically rewrite your Django application to work with Google's data store. Not too long ago, they introduced something called Cloud SQL, which is like a MySQL compliant data store. So you can now, with one line of change in your settings.py, you can now use Google App Engine to deploy your Django apps sort of natively, just using the normal MySQL driver. They also have some nice things like task queues, memcache, blob stores. They do inbound, outbound email. They have WebSocket support using something called Channel API. I found it a bit confusing to get it set up because you have to go to one screen to set up your App Engine app. This is where you manage your actual application, and then there's another login for managing your Cloud SQL instance, and then you have to connect the two together. So that took a little bit of wrangling around to get that working. The Google App Engine app has a lib directory, which, unlike all the other providers where you can actually define a requirements.txt, with Google App Engine you actually have to create a lib directory with all your dependencies and push that up. It doesn't run a requirements.txt on the server. And you also have to run your SyncDB from your local machine against your remote Cloud SQL database. So it's a little bit weird. I found out after I wrote these slides that there's something called the Django Rocket Engine, which tries to make this suck less, make Google App Engine more sane for Django developers. So Django Rocket Engine, if you're going to use Google App Engine, I recommend checking that out. So just to give you an example of what this looks like, can everyone see that? It's a little bit dark. But line 181, you can see that the database engine for Google App Engine, instead of using the one that comes with Django, we're using google.appengine.x.django.backends.rdbms. So that's a special database engine provided by the App Engine SDK. But that's pretty much the only line that I had to change in order to use Cloud SQL instead of using normal MySQL. So one thing you discover when you start playing with all these PaaS providers is that, especially doing them back-to-back like I did, is that they have more similarities than they have differences. So here's an example of what you have to change in your settings.py file for Google App Engine, .cloud, and OpenShift. And you'll see that it's pretty much the same thing, right? There's environment variables that are getting pulled into the settings.py file, and those environment variables are replacing the name of your database, your user, your password, the host. Similarly, App Engine, .cloud, Elastic Beanstalk, they all use a YAML file to describe your application. So this is an example of an App Engine YAML file, and here's a Staccato YAML file, right? So you can define, what services you want to connect to your application, what Python packages you want to get installed, what commands should get run as part of the post deploy, your Django settings module, how you map your static assets. All this can be defined in these YAML files. So once you've snapshotted that, you can push this up to your Git repo, and someone can pull down your code, and they can run .cloud push, and essentially you've now recorded a recipe for how your application should get deployed up to .cloud. So that's pretty cool for making your application easier for other people to get running, because you can just define a recipe depending on the PaaS provider, and it'll just work. This is an example of Staccato's post-install command. So this gets run, sorry, this should have said .cloud. This is a .cloud post-install command. It's just a bash script, right? There's nothing special about it. It creates the database, it runs syncdb, it runs migrate, it makes an admin user, it does the collect static command. OpenShift also has bash scripts that it runs. So this is the deploy script that OpenShift ships with, which looks very similar to what you have for .cloud. So this was my attempt to try to do a matrix comparing, contrasting all the different providers and sort of what versions of Python they support, what versions of Postgres. All of them have a persisted file system except for HEROKU. So with HEROKU, you have to actually store your files on S3 if you want to persist them. They all support, well, all of them support WebSockets except for Elastic Beanstalk. And all of them are extensible except for Google App Engine. So, yeah. So, question, why would you not use a platform as a service? Well, the most common reason is that you've already invested in your infrastructure. You've spent maybe months building something up. You've got all your own custom Fabric scripts, and or you're using Chef or Puppet or something like that, and you've already put enough time and money in it that the switching costs would just be too great for you to move to PaaS. That's maybe not the case if you're just starting out from scratch, or if you don't already have that infrastructure in place and you're just kind of got something hobbled together and it's not really working for you, then you might want to consider moving to a PaaS provider. The other thing that I learned when I was traveling around in Europe is that a lot of Europeans don't like the fact that their data and their application are running on US-based servers, and this can be a big problem. In certain countries, there's laws against that. So that rules out .cloud, that rules out HEROKU, that rules out OpenShift. Well, if you use the hosted OpenShift, you use your own OpenShift, then you could get around that. And lastly, you might have special requirements that just are not met by most PaaS providers. So I have not yet found a Django app that I haven't been able to deploy to any of these PaaS providers. So I think they can handle most use cases, but you might have a really special Snowflake application that does like telephony or has some really crazy requirement, something that won't run on these servers. But more likely than not, your application will run. Would you want to run like an Instagram, a Pinterest, some extremely highly scalable, high traffic site like that? Probably not. You probably want to, run your own servers so you get ultimate control over that. But if you're a small, medium-sized company and you're running a site with moderate traffic, PaaS might be a really good option for you. I want to talk a little bit about the pricing. I hope to do a similar matrix with pricing and actually run this app in production for like a month and see what the cost total. Unfortunately, I wasn't able to do that, but just to give you a flavor for kind of what you could expect to pay, OpenShift gives you 3 gears for free. Gears are like an instance of the application, essentially. If you want more than 3, then you pay $42 a month. And then you pay by the size of the gear. I've got 5 minutes left for questions, yeah. Then we have .cloud. Again, they give you a free tier if you want to run your app in what they call live mode, which means it can scale, it auto heals, they give you guaranteed performance. Then you pay, they have this little sizing thing. So it's $43 if I wanted 2 Python workers and 1 Postgres database. And then Heroku pricing, it's a little bit more expensive for their production database, $59 a month for a live production database, which has no row limits. And then if I have 2 web dynos, that's $35, so my total would be $94 per month. Cloud, Google Cloud SQL, $32 a month for a database instance. And then you would pay for bandwidth as well. So with that, I'd like to thank you all for your attention and open it up for questions. And I want to mention one other thing. the URL at the bottom, if you want to actually play around with the example that you saw on all these different PaaS providers, you can git clone that repo and try deploying Mezzanine to all these different PaaS providers. I'm also working on a little side project called the Django deployer, and if there's interest, I might sprint on it next week. Essentially what I want to do is have a script that analyzes your Django app and creates all the config files to deploy your app to any of the PaaS providers. So you just run one command and it will just spit out all the config files for you, depending on who you want to deploy to. Okay, so any questions?
Thanks a lot for the presentation. That was excellent. I hate to be the bearer of bad news, but Bake Off is a trademark of Pillsbury, and they're really aggressive about enforcing it. There used to be a SIP Bake Off for the Session Initiation Protocol and telephony, and Pillsbury shut them down. So you might need to rename your project, but excellent work.
Good to know. Thanks.
Did you get a chance to look at the routing layers for the different things? Like, I know one of the things that's, I guess, recently become more obvious to some people about HEROKU and some of the others is they have the little dyno workers. And if you have a bad application, like my application and probably a lot of people, where some requests take 10 seconds and some take half a second, you get kind of routing issues where bad, long requests get queued up behind short requests and things are not so
Yeah, so what I think you're referring to is the recent HEROKU debate about how they do their routing. So HEROKU used to do their routing, what they call intelligent routing, where when a request would come in, they would find the dyno, or they would find the least used dyno. And since then, with a lot of growth, they've since changed their algorithm to what they call random-based routing.
Well, I think with Cedar, they changed it, right? Like on the
when they moved from Cedar or from Bamboo to Cedar, they changed it. So now they do random-based routing, which means that sometimes you get requests queuing up, which can cause issues on certain applications, not all applications, but I think Ruby applications in particular have some issues with that.
Well, I'm asking, like, with App Engine, is it, do you have any impression where that's a random routing, or is that OpenShift? Are they all random, or do you have any? I
don't know. We have some OpenShift and .cloud people in the room, so we could ask them. I honestly don't know how they do their routing, if it's similar to HEROKU or if they do something more intelligent. Can you guys answer that question, or?
In the interest of time, we've got a booth. We've got a booth. We can walk you through the routing practices at the OpenShift one in town.
Hi there, thanks for the talk. I've heard about a really cool new platform as a service called pythonanywhere.com, which actually lets you do all your coding right in the web browser. The reason I've heard of them is because that's who I work for. So that was just basically a shameless plug right there. So pythonanywhere.com.
Thanks for that.
Any more questions? Oh.
I'm curious if Amazon Beanstalk pushes their model, are they going to push some of these other providers out of business? I'm unclear how much overlap there is between what Beanstalk is and what these other providers are.
Yeah, so the question is Amazon encroaching on their customers' territory? I think there is some contention. I mean, like, I know HEROKU is on top of Amazon, .cloud is on top of Amazon, and now Amazon is pushing Elastic Beanstalk, which is essentially a competitor to HEROKU and .cloud. So, the question is, how's that going to play out? I don't know. I don't have the answer to that. I mean, I think Amazon wants to keep them as customers, obviously, but there could be some conflict of interest in the future, so it's something to watch.
So for most of the examples you used, you had a requirements file that held all the dependencies. For situations where you need to install stuff at the OS level, so like LXML or PIL, are there passes that do that well? Are there ones where that sucks?
Yeah.
Like what?
That's a good question. Some of them do it better than others. So this is an example of App Engine, which has sort of a curated library of plugins that they support. So there's about 2 or 3 dozen that Google App Engine will let you run, like PIL, LXML, NumPy, SciPy, that kind of thing. But if you have some weird, unusual package that requires C extensions, they might not support it, and you can't run it on App Engine. .cloud and OpenShift. I'm trying to remember which other ones. Most of them allow you to install a system package, just defining it in your config file. So most of the time, as long as that package is in a public repository, an apt-get repository, then you should be able to install it. If it's something custom, then you might have problems.
My question is more about a comparison between monitoring of apps on these various PaaS providers. Is that something that sets one above the other?
So the question is about monitoring. Do you mean monitoring
dashboards and options to monitoring at what granularity and aggregation and filtering that these providers?
Yeah, so a number of the providers I know, .cloud and Heroku have a New Relic plugin. So New Relic is a third-party provider that gives you really deep insight into your application, how long the requests are taking, and it also does more like Pingdom or CloudKick style monitoring, where it'll just tell you if the site goes down. So that's like more deep monitoring, but all of them have sort of like a dashboard that shows you uptime and basic monitoring.
Any other questions? Please give a big hand to Nate. No. Thank you, Nate.